All right, so we're going to have a look at an example now of this hyperbola, and it says it's being dilated by a factor of 4. So that's standard. So we know from that that writing the wrong one, A equals 4. All right. So it then gives you two options or two criteria. The first one is from the x-axis, from the y-axis. So you know that the y-axis is pushing it this way or this way. Okay. So where does that occur? That would occur on the x value. So if you write down your initial point, you've got xy, you're going to have the image equals 4x, like that, and the image of y is going to be the same because it's only pushed it horizontally, not vertically. So now let's rearrange this into x equals. So it's going to be x image over 4 equals x, and this is what we're going to substitute into place of the rule. Did I say at the start that was a hyperbola? I meant to say truncus. So we're going to have, we know that this is image of y equals regular y, so we've got y image equals 1 over, and in this case it's 1/4 x image all squared, because the square happens to the x, and this is now what x equals. So we have to simplify this if we can. So we've got 1 over, now when I square both of those things, I end up with 1/16 x squared. And when I have a fraction divided by another fraction, I can take the denominator and multiply it to the top. So I've got y image equals 16 over x squared. And really that's x image, but you can see how it sort of complicates things sitting in there. So we can actually remove it and just leave it as x squared. So this is now the new rule for a function that has been dilated by a factor of 4 from the y-axis. So it's been pushed away from or towards the y-axis. All right, and you can see how our thinking had to run off the fact that we knew what the images were, and we also had to know that from the y-axis would only push the x value and not the y value because it was a horizontal change. When we come to do the next part, which is from the x-axis, and I'm just going to delete all this. You can go back and have a look at it if you want to. I will highlight the factor of 4 again. Okay, so next one is from the x-axis, and we should know that from the x-axis means that it pushes it vertically. So either away from or to the x-axis. So therefore the change is in the y direction. So our new point is going to have been multiplied by a factor of 4 in the y direction. So we'll start by writing down the image of x is just equal to the original. However, the image of y is now equal to 4 times y. And again, we'll rearrange this to get y equals, and you'll see that it's 1/4 y image equals y. And then we're going to plug in both what we know as x and y in place of x and y in the original. So we've got y equals 1 over x squared. So I'll substitute this in on the left. So I've got 1/4 y image equals 1 over, and we can see that x is equal to itself. So this is just going to be x squared. Then I'm going to multiply the quarter from the left-hand side over to the right-hand side. Sorry, I meant to say divide the quarter. When I divide by a quarter, it's the same as multiplying by 4. So I end up with y image equals 4 times 1 over x squared, which we can then simplify further to become 4 over x squared. So you can see there that the new rule looks similar to the one in the previous, when dilated from the y-axis, but it's a factor smaller, isn't it? The other one was y image equals 16 over x squared. So you can see there's a bit of a difference there. You've just got the important things you've got to remember is that dilation from the y-axis happens horizontally and affects the x value. Dilation from the x-axis happens vertically and affects the y value. And then you have to remember to rearrange to become y equals, because the graph you've been given is always in the form y equals. I hope that makes sense.